Okay, good morning. Today we will talk about software architecture design methods. Last week we discussed the rationale definitions, and we talked about software architecture modeling, distinguish between visual modeling, textual modeling. We have given a short survey of architecture description languages. Today we will discuss the topic of architecture design methods. Actually, we will define a categorization of these methods. So, on the one hand, we have models, but the idea is how do we define architecture, the process, the method. So we will first look at rationale for method, classification of architecture design methods, and also consider the obstacles of each category. What's a method? Actually, most of you know. This is from Webster's dictionary: procedure or process for attaining an object, systematic procedure, systematic plan, a way, technique or process for doing something. Okay. Usually we can make a distinction between methodology and method. Methodology is basically the study on methods. Okay. Like this presentation is discusses methods, so it's actually part of kind of methodology. But in the literature, people also use it interchangeably. Okay. Methodology, software architecture methodology, software architecture method. So in the pure sense, we can make a distinction. Why do we need a method? So why do we need architecture model? We have discussed last week, okay, like guiding the process, guiding the for project management, etc. These are the reasons for why we need architecture design method, or method in general. It provides guidelines for production, defines how to produce something, provides guidelines for verification, provides logical consistency among different processes and phases in design. You could have different phases, but in a method, it's ordered in a systematic manner. It helps to reduce possible errors, and it helps to identify important progress milestones, which is also important from the project management perspective. Okay? So, having a method, it makes sense. So you could say I have lots of models, architecture design models, ADLs, textual descriptions, but you could say I'm going just to design myself, but considering all the benefits of methods, it is wise to adopt an architecture design method. Although it is not easy, because if you look at the literature of software architecture, the majority is actually about architectural design modeling, and not. We can find very few textbooks on which explain the architectural design process. If you look at software, so where's method related? So for that, let's consider this software engineering framework, informal framework. We can just say that software engineering consists of, or software development in general, consists of 4 layers. The highest level we have application layer. These are the applications that we develop. For example, driver monitoring systems, insurance system, command and control system, etc. Then we have a model layer. We build these applications using these models or artifacts. So what is the model? What is in the modeling layer from the architecture design perspective? It's like object classes. If you take object-oriented design, if you took Venom. Yeah, that's general. But if we take architectural design, then we have here typically constructs from ADLs or visual modeling, right? We use these models, artifacts, to develop some application, and typically we do that using a method. Okay. And vertical to these three layers is the supporting layer, which typically includes case tools. Case tools, for example, that support how to visualize, how to draw models. But equally, it could also help how to support the method. Okay? Well, if you take this, so we focus on that. The method. What is the method? What is a method? If you look more into detail, so we said the method describes. It describes how to build application using some artifacts. So in principle, the basic issues are that we have first artifacts. Take, for example, object-oriented design. Typically we have these kind of artifacts. Use cases, classes, entities, attributes, associations, inheritance, state transition diagrams. Right? In textbook on object-oriented design, they typically also define first the artifacts, the models. A class is this and that and that. Okay, a state transition diagram, a use case diagram, etc. Well, to develop these artifacts, we actually apply some rules, implicit or explicit rules. Okay. One rule is, for example, that if you identify some entity in your requirements document, and you could say a rule could be if that entity is important in the application domain, if it's complex, then it's typically a class. Okay. If it describes another class, or if it's a property of another domain concept, then it's an attribute. Okay. So we have such rules, heuristic rules. These rules are not executed in an independent way, but they are related, right? Typically, you don't start directly with defining inheritance, right? To define inheritance relation, you should first have classes. To define classes, you should have first identify entities. Okay? So there's some ordering between these rules. In the unified process, for example, we start first with identifying use cases. Right? Based on this use case, classes are identified. Once we have classes, we can define the inheritance, association, and part of relationships. Okay? So we say the third element here is process. It's a very basic view. Method consists of artifacts, rules, and process. So what's software architecture design then? So typically we have to define software architecture. What are our models and the artifacts, architecture components, the relations, patterns, so ADL. And what's the method? That's this. So the software architecture design method defines what the artifacts are first, what the rules are to produce these artifacts, and what the process is. Okay? The relationships between these rules. Okay? Software architecture design method. Okay, given this, we haven't explained yet anything about method or specific method. What would be an appropriate method, architecture design method, according to you? If you can think 2 minutes about that, we'll discuss. Okay? Yes. What is the first step? What is second step? What is third step? What is fourth step? Any ideas?
start with analysis, requirement analysis.
We start with the requirements analysis. Okay. And then?
Software architecture design.
Then software architecture design. That's easy method.
Maybe we define first components and then their relations.
Okay. You define first architecture component. How do you define the components? What's the source?
Source.
How do you define? Okay.
Yeah, by looking at the requirements part, then requirements design part.
Okay, you look at the requirements, and the components are described in the requirements.
No, in this part, software architecture design part.
Yes, but there are software architecture components. Where do you find these?
By looking at the problem.
You look at the problem.
Yeah.
Mm-hmm.
First specific domain.
First
Specific domain.
First look at the domain. That's also a good one. So we start with the requirements, then you say you look at the problem.
Yeah.
And
Domain.
why domain?
To analyze, to understand the problem.
To understand the problem.
But the domain part, I think it's in the requirement stage part, not in the software architecture part, I think.
Domain part is not in the sorry, I don't get that.
I think the domain part in the requirement stage part, and then software architecture part, and then analysis and design implementation.
Okay.
I think.
You would do like that?
Yeah.
Mm-hmm. Other IDs? IDs on the left. You agree?
I agree with requirement is the first step.
First requirements. And then, so the idea is what's after requirements.
For creating components, use cases and stakeholders.
Mm-hmm.
Interests.
Okay. It's actually not that easy, right? I say define a method, but it's not that easy.
And maybe we first look at what the stakeholders want. And I think it's first step.
That will be an important one. Who are your stakeholders? Okay. But we will come to a specific method. We will discuss that. So it's not easy to define such a method. Maybe that's also the reason why we don't have many textbooks which describe software architecture design method. It's easier to describe software architecture model. The notations, right? The process is more difficult. But there are several researchers, many researchers have still focused on on defining a method. This is not comprehensive, just an example set of methods which includes some process which define a process to define software architecture. The unified process, with architecture-based patterns, pattern-based architecture, etc. They are just examples. So, there are some methods which we can actually, which are still different in the way how they approach designing software architecture. The problem here is which one should we select? We could of course design our own method, which we actually did, but we could also look at existing methods. Which one should we select and why? For which reason? For that actually we have classified the architectural design methods. Let's first categorize these methods. There are some methods, architectural design methods, let's categorize them. So, and then decide. We have classification we can do based on two issues actually. The first one is the scope. What is the scope that the method is focusing on? The granularity, the scope actually. And the second one is the source of the architectural components. If we consider first the scope, we can distinguish between two types of methods. Methods which have a single system scope, so which define the set of rules to design an architecture for a single system, single application. Right? The second category is the multi-system scope. It's basically software product line engineering or software family engineering. There the focus is on designing architecture for a set of related products. Okay? So one architecture, and the goal is that it should be model the architecture of a set of products, and the set of products is the product line. Okay? In this course, actually, we focus on single system scope for now. In the course of software product line engineering, we focus on this. Okay? There we make a distinction between actually two types of architectures. So in this one, a reference architecture or product line architecture, which is the architecture, the higher level design. It's even higher than the architecture for single system scope. It's architecture for multiple products. For example, product line architecture for insurance system products. Okay? And we make a distinction between application architecture and reference architecture. This is the product line architecture. Application architecture is a specialization of this product line architecture. Okay? And this is actually a single system scope. So I will not elaborate on this, but it's just true for the classification. There are methods which focus on multi-system scope architectures. Okay, the scope. In this course, as I said, we focus on single system scope. I have one application, one product. How can we derive the architecture from that? The second classification criterion is the source. So what did we say? Actually, the definition: architecture consists of is the gross level structure consisting of components and their externally visible properties, the guidelines, etc. So the component, architectural element, is actually an important issue there. And the second actually classification is actually based on that. What's the source of these components? Or in general, architectural elements. Could be also relation. Architectural component, architectural relation. There we distinguish between four types of architectural design methods, software architectural methods. First one is artifact-driven, use case-driven, pattern-driven, and domain-driven approaches. Artifact-driven approaches derive the components from the requirements using artifacts in the method. I will explain this in a minute. Use case-driven approaches basically take use cases as the source of architectural components or the driving force. The pattern-driven approach derives abstractions, the architectural elements, components, or even almost the complete architecture from patterns. And the fourth one, domain-driven approaches, derives architectural elements, the abstractions from solution domain, through domain analysis process, which is actually the focus of this course. So we will focus on domain-driven approaches, which also applies patterns. Okay. But let's look at these four methods separately. Artifact-driven approach is quite an old one. We can find this approach in some older textbooks on object-oriented design, but also sometimes it's also still in practice, okay, in the state of the practice. So what's the point here? What's the process? You start from textual requirements, actually like most, if not all, architecture design methods do. You start with the requirements. In these requirements, they look at the artifacts types. They try to find artifact types which are described in the method and try to find these in the textual requirements. And once these artifacts are found, these artifacts are grouped, and the groups or the subsystems, the packages, are called architectural components, and the relations between these subsystems are defined, and the result is called the architecture. Okay? For example, well, this is the process. First, we have client. This describes the requirement specification. These are the artifacts which are described in the method. For example, class. By looking at class is some complex entity, tries to find it here. Okay. If you take very old methods, for example, OMT, object modeling technique, an older technique, then typically they start to identify nouns in the requirement specification. And based on that, so you get the grouping of these artifacts. There's lots of general knowledge applied here, and the composition of these components are called architecture. Let's look at an example. It's an example that you know. Imagine we are going to define a software architecture for a PC factory. A software system for a computer company consists of two departments: a factory and sales and marketing department. Factory assembles desktop PCs and tower PCs. All the components of a PC are different by different external suppliers. A PC consists of one monitor, cabinet, etc., etc. Okay. Just the company and tries to develop personal computers. So the artifact-driven approach, we are going to define an architecture for this using an artifact-driven approach. For example, as explained in OMT. In OMT, there are, as we said, it describes the artifacts, but also the rules to produce these artifacts. For example, the first rule: extract nouns from the problem statement, from the requirement specification. You just define the nouns. Select these nouns as tentative classes. Okay, that's a rule. Then follows a set of rules. If this tentative class is redundant, eliminate. So it's not a class. If it's relevant, you take it as a class, etc. If tentative class is attribute, then select tentative class as attribute, etc. This is not the complete list. It's also not described in this way, in this method. We just extracted these ourselves. So, but in any case, for every type of artifacts, we can identify some heuristic rules. Also rules for define the relations, okay, or association. So this is the process. We have requirement spec. This is our architect. She looks at the method, the rules in the method, and tries to identify class the artifacts here. Okay. Imagine these artifacts are identified. The computer, desktop, monitor, cabinet, tower PC, chassis, factory, etc. So then the next step here is to group these classes. Okay. You could, for example, group like this. You could say these are the elements which are called computer. This is a department. We have order is separate, and that's supplier. Based on our general knowledge and knowledge on the domain, we define the relations. See? So we took the requirement specification, we took the method, the artifact descriptions, and scanned the method. Try to identify the classes. Once we have identified the classes, group these and define the architecture. So then typically you could say this is my architecture based on the subsystems. Company has factory, produces computer. Company has a sales department, sales, etc. Okay. Details are not important here, but just the process of doing or of designing an architecture. So the question here is, are these the right abstractions? Why? Is anything missing here? So what was the source here? The textual requirements, right? So what is missing here? We get these kind of questions. Are these the right abstractions? Why is anything missing? We don't know, right? Do we know? What do we depend on? What was the first thing what we looked? The source. Here. What was the source? The requirements here, right? And we scan these. So, how do you know that these are the right abstractions, the components? How do you know if something is missing? A PC factory we are going to design. Actually, we don't know. Right? And that's also the problem. So, basically, these requirements in general are not precise. Of course, we try to make it as precise as possible. It's also usually ambiguous, redundant, difficult to understand, can also not be complete. Especially if it's just written from the client's perspective. If you have not taken domain into account. What are the obstacles here? Textual requirements are imprecise and are less useful as a source for deriving architectural abstractions. Architectural abstraction here we mean architectural elements, the components, the relations, the structure. The subsystems are just grouping mechanisms, have poor semantics to serve as architectural components, and also composition of these subsystems is not well supported. Okay. How do we know? So first identify the components, then the relations, but usually in these kind of methods it's not well explained. It's clear, this? So would you use this approach? this is one method, right? Why not? Because of this. Alright. Then we come to the second category, use case driven approach. This looks a bit similar to the artifact driven approach. We could even also say, we could maybe categorize these two as requirements driven approach. With driven we mean like the source is derived directly from the requirements. We don't say, so be aware, we don't say that we should not do requirements. Okay? But the point here that is actually what you said actually in the beginning. What Yusuf said, so we do the requirements and then architecture. But we don't do like that, right? So requirements and then architecture. That's the step actually. Right? But you can also mean that requirements and then there's the whole architecture design process. Of course. Use case driven approach. There we extract use cases, identify the fundamental classes from use cases, using these in the use case, right? We define scenario interaction diagram, define the classes, etc. Then there's a process where we define the packages, also grouping mechanisms, and define the relationships. This is the conceptual model. Client provides some requirement specification. Then we define the use case model using domain model and business model. Okay. But it's a bit informal here. It's not like the domain-driven approach as we know. Based on that, we follow with analysis design models. We identify the artifacts. Then we group these artifacts into packages, and the packages are then called, the relationship between these packages are called architectural description. Example. I want to carry my goods and or persons from one place to another. The carrier must be able to fly, go forward and backward, accelerate, turn left and right, and stop. Okay? This is kind of requirements. Use case driven approach. We define the use cases. Carry goods, fly, turn, move, accelerate, stop. And we define as use case diagram, but in any case we say these are the use cases. We could have actor and the ovals, right? Then we define the user interface, carry goods, where we show actually kind of that, so where we show how the user can interact with the system. These are the use cases, and based on that, actually we try to define the architecture. So we say, okay, this is carry goods, move, turn, stop, accelerate, fly, and others. So actually, the source now is, the primary source here is then actually implicit or explicit, the use cases. But people tend to, so deriving solutions directly from the use cases. What people tend to do is just put the term management for these use cases: move management, acceleration management, turn management, stop management, goods transport management, etc. And then define the relationships between these and come up with an architecture. Okay, this is also one approach, okay, based on use cases. If we consider the ideal architecture, in this case it's about designing a plane This is what we found, but the ideal architecture, which is actually in the domain, will be radically different from the one that we have defined using use cases. Okay. Here we have move management, good transport management, acceleration, but here we talk about cabin, engine, interior wing, etc. So the abstractions are different. Okay. What are the problems of an architecture with inappropriate or wrong abstraction boundaries? Abstraction boundaries here mean that you have the right architectural elements, the right architectural components, the relations. That is, if you put it differently, what is the problem of defining a wrong architecture? This is what we did. This is what was expected actually. There should be a problem, otherwise there would not have any method, right? Then you should just go ahead. What's the problem?
We didn't offer specific solutions. We said that only, for example, carriage manager, but we didn't handle how we carry it. We didn't design it.
Carry management was basically from use cases, right? Provide external perspective. But what we are going to should design is actually also the internal perspective, right? So it somehow fails also, this use case driven approach. It focuses on the external perspective of the system. Based on that, tries to identify the classes, and also actually it also states in informal manner, look at the domain and business domain model and business model, but there's no explicit systematic approach for what we call domain analysis. Okay? So we will end up then with some architecture, but the structure of this architecture will not be similar to the structure that we expect. Okay? Then actually, like, it will be all these structures. Actually the use case will be just cross-cutting the components what we have. Carry management. Why is this bad? For reuse, okay, for adaptability, for evolution, for understandability, etc. Well, if you look at detailed design, for example, this from Boeing design, it appears that we have lots of domain concepts described in domain of constructing planes. But if we look only at the use case diagram or use cases, then these domain concepts are not explicit. Okay? But there's lots of literature. This is an example on airplane design. Right? So, what would you do then? So you said, Ahmed said that, I guess, you should look at the domain. Right? And this is what you meant. So, we have the requirements. Then we can go directly to the architecture design. Actually, we can do by the more traditional, by artifact driven. Okay, try to find the class and textual requirements. Or we can do a more recent approach, use case driven. But actually the bottom line is that they are almost similar, because requirements to architecture, almost. And we actually neglected the domain. We didn't look at the domain. We didn't have an explicit process for doing what we say domain analysis, to identify to identify these concepts. Fuel system design, landing gear design, integration of propulsion system. They are all actually in the domain. Okay. With use case, well, this we could build some plane, but not the plane that we actually hope to get. Okay. Can build small systems, but not the huge systems, the palaces, right, that we talked about in the first lecture, the Taj Mahals. So, summarizing, what are the obstacles of use case driven approach? What's the obstacle? Problems.
It is very abstract since we do not see the domain well.
Mm-hmm.
And we do not know especially what is our requirements or what is need to be done.
Mm-hmm.
It is very abstract to say that fly management and such as like the, as I said.
Mm-hmm. Good. Domain is actually implicit in the use case. The requirements, textual requirements or use cases are imprecise. Selecting architecturally relevant use cases is actually not systematically supported. So we talk about use cases, but use cases can be at actually different granularity levels. So how do you select the architecturally relevant use case? This is of course the first very key obstacle. It's basically the external perspective. This second one is not systematically supported. Actually, they do not provide us a solid basis for defining architecture. Okay? That's the second one. The third approach is pattern-driven approaches. This is actually it's a nice approach. We start with requirement specification again. Then what we do is not try to identify classes and so on in these requirement specification, but we try to identify existing architectural solutions, architectural patterns. Okay? We said we have these requirements, we could say, oh, typically this kind of system is solved by that kind of pattern. So we select these patterns from a pattern base. A pattern base are the textbooks, the books, the literature that describe these patterns. Okay, layers pattern was well known here, right? Client server pattern. And then we say we compose these patterns. Okay. What's a pattern? It's a generic and reusable design solution for recurring problems. Perhaps you have seen the notion of object-oriented design patterns, I guess, in 319, object-oriented design. So each pattern describes the solution problem and the context. Patterns can be used at the object-oriented design level, like composite pattern. We have observer pattern. They are basically patterns for detailed design, but we have also patterns for architecture, like layers pattern, blackboard, pipes and filters, model view controller, etc. Okay. We'll discuss this in more detail in the lectures on architectural patterns. But now it's just the notion of, we look from the perspective of method. We have pattern, and so that this is the third category, a pattern-based architecture design approach. So if we define a conceptual model here, we start with the client. Can we do the requirements analysis. How do we identify patterns? In general, is based on the general knowledge. There are some guidelines in the pattern-based books, but very often it's just the general knowledge is applied. To do what? To identify the pattern. To identify the pattern, which is probably a solution for your requirements. A pattern is described. Basically, it defines the goal, the intent, the context, the problem, solution. So actually what you do is you try to match. If this goal matches with the goal in the requirements, then typically it could be used as a solution to your requirements. You define 1, 2, 3 patterns, you refine them, you compose them, and you get your architecture. Okay. So why is this a better approach than just a requirements-driven approach? Or, so if I, which one would you prefer? Requirements-driven or pattern-driven? Which one? Pattern, why?
Well, it's the architect's point of view rather than the customer point of view.
Right. That's one. What else?
And additionally, it's tried before and it worked. We know that.
Very good. It has been tried before, which means we say it is a generic solution to recurring problems, right? A pattern is actually an expert knowledge, consensus of experts. It has been tried before. It is at the architectural level, very good. So it's not just the external perspective, but it's really architectural level. It makes so this pattern-based approach is better than the requirements-driven approach. What are the obstacles?
Maybe we cannot find required pattern for our problem.
Right, very good. It's not easy to find the required patterns. What else? Does an architecture only consist of one pattern? What if we need multiple patterns? Integration, composition is not easy. Selection of patterns is not easy. Composition of the patterns and application of the patterns. You could identify the patterns. Okay, layers pattern, model view, controller pattern, but the application is not easy. Composition, you have layers pattern, you have some MVC pattern in it, client server. How do you compose? Is also not well supported. The first one is also very important. Patterns provide a generic solution to recurring problems within some context, right? But your domain could be quite large. As such, the patterns might not be able to integrate all these, or to identify, to match all these concepts that you need. So patterns only might not be sufficient for deriving all the required architectural abstractions. Okay? We will break in 5 minutes. The last one is domain-driven approach. There we define requirements. What we then do is not directly architecture design, but we first do domain analysis, and actually in domain analysis also includes problem analysis, as we will see. This was the right track, what you said. And we try to extract architectural abstractions from domain model concepts. Plus, the relations between these domain model concepts are defined also based on the domain model. like in the airplane design. You have requirements. What we first do is, what is the domain of airplane design, airplane construction? What are the concepts there? Identify these elements. What are the relations? Okay. This is the approach. So we client classification. Then this is the key. Domain analysis process. We first define domain design, domain model. Based on domain model, we define the architecture. So the focus here, the source is actually the solution domain. It's not the artifacts, the requirements, not the patterns, but directly the domain, the solution domain. Okay, and actually that will be the focus of this course, domain-driven design. Integrate with pattern-driven design. So we will start with the requirements, do domain analysis, problem analysis, domain analysis, define domain model, apply patterns. Okay. Why? So artifact-driven, use-case-driven approach, or approaches which look at the requirement specification to identify the architectural abstractions, may fail short in finding the appropriate abstractions, and as such provide a robust architecture. We don't want our architecture to change every time, right? It should be stable. Patterns are useful, but it might be difficult to discover, select, combine, apply, and compromise patterns. In this course, we will focus on domain-driven architecture design approaches. Questions? Clear? Okay, let's break again 10 minutes, 10 to 15 minutes.